Students, Sairam, this is Megha Miss here, and today we will continue with our lesson number 12, study of sound. This is our session 3 students, okay. Now till now you have studied in the last session, we have seen different types of sounds are there, audible sounds are there, yes, which can be heard by the humans, yes, humans can hear them. That is between the frequency range of 20 Hertz to 20,000 Hertz, right. Then the sound waves which are of the frequency less than 20 Hertz are your infrasounds. And your ultrasonic are which sounds students which are more than 20,000 Hertz. Okay. So you have studied about this. Ultrasonic sounds are ultrasounds. Okay. So we have studied till here. Now we will continue. Also yes, you studied about the laws of reflection are obeyed by the sound waves also. Yes, so using that we are going to study today the new concept, okay. The next concept which you are going to study students is the echo. Now you must have visited an echo point at a hill station. Now many of you have, okay. If you shout loudly at such a point, you hear the same sound just after a little while. Yes, you know this. Nothing to explain in this. I think students, most of you must have heard your echo. Okay. This sound is called an echo. So important in this is to remember the definition, students. What is the definition? An echo is the repetition of the original sound because of the reflection by some surface. Okay, students. Again, I'll repeat. An echo is the repetition of the original sound because of its reflection by some surface. So you can be a source, a mountain can be a reflecting surface. Okay. Now in order to be able to hear the original sound and its reflection distinctly, means clearly if you want to hear it. Now for example, if I am taking at 22 degrees Celsius. So what must be the minimum distance, students, between the source and the reflecting surface? So now to calculate this, we can calculate this, students, okay. So to calculate this, at 22 degrees Celsius, the velocity of this sound in air is 344 meter per second. You will remember this, students, okay, this value. At 22 degrees Celsius, the velocity of this sound in air is 344 meter per second. So our brain retains a sound. Retains means it can keep a sound, okay, with it for 0.1 second. So thus, for us to be able to hear a distinct echo, the sound should take more than 0.1 second after starting from the source to get reflected and come back to us. Okay, students, so you will remember, to hear the distinct echo, clear echo, the sound should take more than 0.1 second after starting from the source, okay, to get reflected and come back to us. So it should take more than 0.1 second, okay, to come back to you after getting reflected. Then only you will be able to hear the distinct echo. Okay, students. Now, thus we can determine the minimum distance between the source and the reflecting surface as follows. So we can calculate it as I told you. So first we will use the formula. Distance is equal to speed into time. 344 meter per second into 0.1 second, right? You are getting the value as 34.4 meter. Okay. Now we will see what to do with this value. Now thus to be able to hear a distinct echo, the reflecting surface should be at a minimum distance of half of the above. Okay, so whatever value we have got, 34.4. So if I want to hear a distinct echo, that 34.4 I have to make it half. That will be 17.2 meter. Okay, so this much is the minimum distance. So as the velocity of the sound depends on the temperature of the air. Yes, we have seen this at 22 degrees Celsius, students. Okay, so as the velocity of the sound depends on the temperature of the air, this distance depends upon the temperature. So the temperature is more important, students. Okay, remember, for the velocity of the sound, okay, at that particular temperature is important. Is it clear, students? I hope you understood this calculation also. Okay, we'll move to the next part, that is reverberations. Now sound waves gets reflected from the walls and the roof of a room multiple times. Now this also happens. This causes a single sound to be heard not once but continuously. Okay, sometimes this may happen. This is called as reverberation. The time between successive reflections of a particular sound wave reaching us becomes smaller, and the reflected sounds get mixed up and produce a continuous sound of increased loudness which cannot be deciphered clearly. Means you cannot distinguish clearly what is going on, but a continuous sound you will be hearing because of the multiple reflections. Okay students, now this is the reason why some auditoriums or some particular seats in an auditorium have inferior sound reception. Okay, so for this is the reason, because of the reverberations, some of the auditoriums or some particular seats in an auditorium have inferior sound reception. Okay, you can see here, now you can see here a singer is sitting now and someone is hearing here, audience. Okay, so you can see sometimes his voice, see how many times it is getting reflected. You can see here reflection is taking place, while sometimes it can go directly to him. So the listener, or you can see who is the audience, what will happen, he may be able to hear many of these sounds together, only one single sound may be coming which he cannot decipher clearly, he cannot hear it clearly. Okay, so what we are using, inferior sound receptions. Okay, so I hope it is clear. This part diagram, it is given in your text, you can go through. Okay, now sonar, next system we are going to study, that is the sonar system. Now what is this sonar system students? Sonar is the short form for sound navigation and ranging. You will remember the full form for the sonar. In the short form, yes, sonar, it is the short form for sound navigation and ranging. It is used to determine the direction, distance and speed of an underwater object with the help of ultrasonic sound waves. Okay students, so again I will repeat it. It is used to determine the direction, it will tell you the distance and speed of the underwater objects. Okay, with the help of which sound students? Ultrasonic sound waves. Okay, sonar has a transmitter and a receiver which are fitted on the ships or boats. Okay, remember, sonar has a transmitter and a receiver which are fitted on the ships or the boats. Okay students, so we'll proceed to the next part. The transmitter produces and transmits ultrasonic sound waves. Okay, so the transmitter produces, it will produce and transmit ultrasonic sound waves. These waves travel through water, strike underwater objects and get reflected by them. Okay students, so here you can see the diagram, okay, where you can see the ship, and as it is told that on the ship or the boat the transmitter and the receiver is featured. Okay, now here is the transmitter which it is written, it will give the transmitted pulse. Okay, water is there. Now for example, here is the object bottom. Okay, see here, can you see? This is the object. For example, this part is your object down. Okay, at somewhere point here. Okay, where that both the lines are joining, you can see. Okay, so what it will do, these waves will travel through the water, strike that underwater object, and see, you can see it is getting reflected back. Okay, you can see reflection pulse is written and it is a seabed written. So in seabed some objects have fallen, you can get the distance. Okay, so the reflected waves are received by a receiver on the ship. Can you see a receiver is there here? Okay, now we'll just proceed to the next part students. The receiver converts the ultrasonic sound into electrical signals. What the receiver will do? Receiver will convert the sounds into the electrical signals, and these signals are properly interpreted. Okay, interpreted. So these signals are properly interpreted. Okay, so the time difference between transmission and reception is noted. Again, the time difference is also seen, how much time the sound took to get transmit and it got back. Okay, this time and the velocity of sound in water gives the distance from the ship of the object which reflects the wave. So this can tell you, when you get the time, from the time and the velocity of the sound in water, you can calculate the distance, the ship from that object from which the waves are getting reflected. Okay students, I hope you understood this part. Okay, now we'll just proceed to the next part. Okay, so sonar is used to determine the depth of the sea. Okay, so yes, you can also use this sonar system to calculate the depth of the sea. Sonar is also used to search underwater hills, okay, valleys, submarines, icebergs, sunken ships, etc. Yes, all these things can be easily found out with the help of this sonar system. Okay students, which type of sounds the transmitter is transmitting? Ultrasonic sounds. Okay, so basically you will remember that your sonar system, it is based on the ultrasonic sounds. Yes, and this ultrasonic sounds, they are transmitted, they go and hit to the object. Now these objects can be anything, as we have seen. Now they can be underwater hills, they can be valleys, they can be submarines, they can be icebergs, they can be sunken ships. Okay, many things can be there. Okay, so they will, the ultrasonic sounds, they will go, hit them, get reflected back, and the receiver will receive it. Okay, now these sounds which are received, what they will, the receiver, what it will do, it will convert it into the electrical signals. Okay, and this electrical signals will be interpreted, okay, on the computers using technology and all. Okay students, and yes, you can understand what an object is there. With a, they also calculate the time for which the transmission and reception has taken, the difference between the time. And if you have the time, if you know the velocity of the sound in the water, of course students, you can calculate the distance of that object underground, whatever that object, from the ship. Okay, and like this you can also calculate the distance for these different types of the substances, or you can say the, not substances exactly, the whatever the things which are there, which are underground. Okay, so the sonar system is very useful, only it is important that it makes the use of the ultrasonic sound. So we should have that much capacity transmitter which can transmit this ultrasonic sound near the depth. So depth of the sea can also be calculated. If you don't want to, nothing you want to find out in the sea, but at least if you want to calculate the depth of the sea, yes, you can use the sonar system. Okay students, I hope this part is also clear to you. Okay, so students, we have come to the end of today's session. So today we studied about students echo. What was echo students? Echo is nothing but it is the repetition of the sound waves when it is getting reflected back by some surface. Okay, and yes, you must have heard the echo many times. Yes, then we saw about the reverberations. Yes, what were reverberations? That the sound waves, they are getting multiple reflections taking place, right? It can be in a closed room. Yes, so we have seen an example of auditorium, right? That yes, sometimes you can see a continuous sound can be heard, only a single sound can be heard because of the multiple reflections, but that single sound which you will be hearing, it is not clear. Okay, then we saw about the sonar system. Yes, what we saw in the sonar system? Yes, this system we are using for calculating the depth of the ocean bed, or you can use for detecting the submarines or the underwater hills and all. Yes, we saw many examples. And in the sonar system you have a transmitter and a receiver, right? Transmitter will transmit the ultrasonic sounds which will go and hit at the bottom to any of the object which is there, and it will be getting reflected back, and the receiver will receive that sounds, will convert it into the electrical signals, and yes, you can get to know what the object it is. Yes, also the distance can be calculated of that object from the ship or whatever is moving. Okay, so I hope whatever we have studied in the today's part, you have understood it. Go through the presentation properly students. We'll meet in the next presentation. So study this till that time. Okay, thank you, take care, Sairam.